Here we have a picture of a syringe with some gas trapped inside it. We're going to compress it to half the volume. In this case, the pressure is going to double. If we compress it again to a third of the volume, then the pressure would triple. And let's say we expand the gas, we expand it times 4 the volume. Then in this case, the pressure would actually decrease to a quarter. Okay, we can say that pressure and volume are inversely proportional for a fixed amount of gas, provided the temperature is constant. We can write this as an equation. You may have seen in maths using this symbol. Pressure is inversely proportional to volume. Now we can turn this into an equation with an equal sign if we put a constant k like this, which I'm just going to call a constant. Okay, and then I'm going to rearrange this, bring the v to the other side. So PV equals constant, which is a very useful equation, and we can use this whenever the temperature is constant. And we can do some maths with it to figure out pressure and volume. We can also write in this form, P1V1 equals P2V2. P1 is the pressure at the start and V1 is the volume at the start. P2 is the pressure afterwards and V2 is the volume afterwards. So let's practice using this equation. Example 1, we have a diver who takes a breath of air at a pressure of 400 kilopascals and a volume of 1,500 centimeters cubed. This was when they were at a depth of 30 meters underwater. As the diver rises to surface, the pressure drops to 100 kilopascals. Okay, calculate the volume of the air at the surface. That's what we're trying to do. So let's write the equation out. So P1 is the pressure at the beginning. So that's 400 kilopascals. So I can write 400,000. You don't have to convert actually. As long as you use the same unit on both sides, it's fine. So for pressure and volume, as long as you use the same unit on both sides. The volume at the beginning, deep underwater, was 1,500. Pressure when it rises to the surface, it decreased to 100,000 pascals. Okay, and then V2 is what we're trying to find. So divide both sides by 100,000 and we get a final volume of 6,000 centimeters cubed. Now this makes sense. If you look at it very carefully, the pressure has become a quarter. So that means the volume should become times 4, which is what we see. State the assumption you made in this calculation. Now remember, you can only really use this equation if the temperature is constant. So that's an assumption we made. Also, we're going to assume that the diver isn't breathing any air out because it should be a sealed container. So we're going to assume the lung is like a sealed container, there's nothing coming in or nothing leaving. Okay, final example here, I've got a balloon which has a volume of 0.50 meters cubed at sea level. The balloon is then taken to the top of a mountain where the air pressure drops to 70 kilopascals. The balloon has expanded to 0.72 meters cubed. Calculate the pressure of the air inside the balloon at sea level. Okay, so we need to calculate the pressure at the beginning, basically. We can assume the temperature is constant, so we can use this equation. P1 is the pressure we're trying to find at the beginning of at sea level. Volume at sea level was 0.5, and the pressure at the top of the mountain was 70,000 pascals, and the volume at the top of the mountain was 0.72. Okay, so now we divide both sides by 0.5 to get the pressure at 1. So divide both sides by 0.5, and you get 100,800 pascals.